Welcome student in Christchurch Convent Digital Classes, Subject Chemistry, Class 12th, Chapter 3 Electrochemistry. In this video we'll see about electrical resistance. So what is electrical resistance? It is obstruction in the flow of current caused by the metallic wire or electrolytic solution which is present in a container or in a cell. It is measured, it is denoted by the symbol capital R. It is measured in a unit called ohm, omega, with the help of a Wheatstone bridge. The electrical resistance of a metallic wire or of an electrolytic cell is directly proportional to the length of the wire, metallic wire, or the distance between two electrode of an electrolytic cell, that is anode and cathode, and inversely proportional to area of cross section capital A of electrodes or metallic wire. So in symbolic language, R is proportional to 1 upon A and R is proportional to L. So if we combine with these two, we will get R is proportional to L upon A, or R is equal to rho into L upon A, where rho is a constant of proportionality constant which is called a specific resistance. Now in the equation, the constant of proportionality denoted by rho or called rho is called resistivity or specific resistance. It is measured in units called ohm meter. If when length is 1 meter, that is the distance between two electrode is 1 meter, or the length of the wire is 1 meter and the distance between two electrode is 1 centimeter, and if the area of cross section is 1 meter square or 1 centimeter square in case of electrolytic cell, then the resistivity become the resistance, specific resistance, one omega meter is equal to 100 omega centimeter, and 1 omega centimeter is equal to 0.01 omega meter. These are the relationship. Now electrical conductance. The inverse of resistance is known as electrical conductance, that is G is equal to 1 upon R. So in this slide, R is equal to rho into L upon A. So here 1 upon RA become rho into L is equal to A. Or 1 upon rho is called kappa. 1 upon rho is called kappa, and A upon L is cell constant, reciprocal of the cell constant A upon L, because L upon A is cell constant. So it is measured in a unit called Siemens, represented by the symbol S. It is equal to ohm inverse, also known as mho or omega inverse. The electrical conductance depend on the nature and the structure of the metal of which electrodes are made or cell is made. The number of valence electrons per atom present in atom or per atom. So mathematically G is equal to 1 upon R or A upon rho into L, or 1 upon rho become kappa K, and A upon L is the reciprocal of cell constant 1 upon C. Electrical conductance decreases with the increase of temperature and vice versa, is also true. So you can see one electrolytic cell is given here, anode with yellow color and cathode with gray color, and one battery is connected between anode and cathode, and molten NaCl is taken as an electrolyte in the container. When we connect a battery, and then current starts flowing from positive terminal to negative terminal, so outside the cell current will flow from positive terminal to negative terminal, then it go into the electrode, then through solution, and electrical conductance in the solution is due to Na plus and Cl minus ion. Free ions are responsible for the electrical conductivity. Then current again goes to cathode, and from cathode to negative terminal of battery. So this is the electrolytic cell for you, and E minus direction shows the flow of electron, and the direction of the current is always the opposite of the flow of electron. The free ions Na plus and Cl minus present in the solution are responsible for the conductance in a solution, electrical conductance in a solution. The inverse of resistivity is termed as conductivity. So omega is equal to 1 upon kappa. It is represented by the symbol Greek kappa. K type symbol is called kappa. It is measured in the unit called Siemens meter inverse. When the length is 1 meter and the cross section area is 1 meter square, then the conductivity become conductance. The conductivity of an electrolytic solution depends on first nature of the electrolyte added in the solution, size of the ion produced, and their solvation energy in the water or solvent. Nature of the solvent and its viscosity, concentration of the electrolyte, it increases with the increase of temperature, and sixth is pressure. So matter can be classified into conductors, insulator, and semiconductors depending upon the magnitude of their electrical conductivity. So what are conductors? Solid or electrolytic cell with conductivities ranging between 10 raised to power 4 to 10 raised to power 7 ohm meter inverse are called conductors. Metals have conductivities in order to 10 raised to power 7 ohm meter inverse, so is good. Metals are good conductor. For example, iron, copper, silver, aluminium. So metal is used as the tip of the plug that can be inserted into the socket because they are good conductors. Insulator are the substance which do not conduct electricity, and solid with very low conductivities ranging from 10 raised to power minus 20 to 10 raised to power minus 10 ohm inverse meter inverse. For example, wood, plastic, cloth, dry cloth, and glass. So these are the bad conductors. or you can say insulator. Semiconductors, solid bit conductivity in the intermediate range of 10 raised power minus 6 to 10 raised power 4 ohm inverse meter inverse. For example, germanium, silicon and gallium are the semiconductor. The conductivity of semiconductor are in the range between solid and between conductor and non-conductor or insulator.